Okay, so this is a 5-4 question. You receive a shipment of 13 televisions. 3 of the televisions are defective. If 2 televisions are randomly selected, compute the probability that both televisions work. What is the probability at least one of the 2 televisions does not work? So there's different ways to handle this problem. This is the way I kind of think of it. It might or might not help you. Oops. So So for the first one, to try to get 2 working televisions in a row, I would do the probability that the first works times the probability that the second works, given the first one worked. Okay, this is for part A. So the probability that the first one works, let's see, you've got 3 defective ones out of 13. That means 10 of them are working, right? 10 of the 13. So just choosing one television out, your probability of getting one that works is 10 out of 13. Now, remember, picking up one that works out of the first time reduces your chances that you'll get one the second time, because now there's only 9 working televisions out of 12 total televisions. So you just multiply those 2 probabilities together. Let me do that real quick. Equals 10 13ths times 9 12ths. So it looks like you got about, I'm not sure, usually it's to the 3rd decimal place. So let's do 0.577. 0.577, let's just see. Yeah, 3 decimal places. The probability is about 60%, almost 60%. Now, the second question, what is the probability that at least one of the 2 televisions does not work? Okay. Now, if you think about that, that can happen in a couple different ways. So I'm going to use B for broken. You can get a broken one on your first pick and a working one on your second one. You can get a working one on your first one and then a broken one the second time you pick, or you can just get 2 brokens. Okay. And we can calculate using this kind of conditional probability. We can calculate the probability of each of these situations and then just add them up together to get the probability that you get at least 1 broken television. But if you recognize something, it makes it kind of it makes the problem a little easier. So the only situation not covered here, or the complement, right, of getting at least 1 broken television, is getting, getting 2 working televisions, which is the probability that we calculated in the first situation. So really, the probability that we get a broken television is really the complement of this probability right here, right? Because everything that's not getting 2 working TVs has at least 1 broken television. So what I can do, a slick way to do this, instead of calculating each of these 3 probabilities, adding them up, is just doing 1 minus, right, 0.577. Okay. Right? 0.423. To get it, and that's, the complement is often a very convenient way to get things. And so if you recognize that the complement of the thing that you want to calculate, the probability that you want to calculate, is easy to get, you can just use the complement and then subtract that from 1 to get the probability of this stuff happening. So if we calculate individually each of these 3 cases, they should add up to 0.423. So I hope that helps on this one a little bit.